So yesterday we worked on two-step equations where there were two numbers that we need to eliminate to get the variable by itself so we could solve the equation, find out what x equals or n equals or whatever the variable is. Today we're going to continue looking at two-step equations, but we're going to look at some special cases. So yesterday we looked at the basic cookie-cutter two-step equation. Today we're going to look at some that look a little differently, and we actually have to kind of go about our process a little differently. So if we look at number one, we have 6 plus n over 9. So I have addition and I have division, and my n is here. So the 6 and the 9 are going to have to go away if I can get it by itself, right? I need n equals something. So I need to get rid of the 6. I need to get rid of the 9. Now, on our two-step equations that we looked at yesterday, we always went after the lonely number first, which was the addition. But if you look, this n and the 6 are all the way on top of this fraction. They're stuck on top. This whole quantity is getting divided by 9. So if I was doing this forwards, like if I knew what n was, if I told you it was 3, and I asked you to solve this, you would do 6 plus 3, and then you would divide by 9. On this type of equation, we always do the top first and then divide. So it's kind of like it's in parentheses up here. You do the top and then you divide. So if I'm going to reverse everything to try and go backwards through this problem, I actually need to think about what was the last thing I would do. The last thing I would do is divide. So as I work backwards, that's actually the first thing I would do. Because if I knew what n was, I would add 6 and then divide by 9. And I should get 1. So if I'm going the opposite direction, the last thing I did was divide by 9 to get 1. So I actually need to multiply 1 times 9. And then the very last thing I'm going to do as I work backwards is subtract the 6 that I added to get back to where I started. So when you see problems like this where the entire expression is on top of this fraction, you're going to need to get rid of the bottom first. Basically, I like to think of this whole expression as being stuck on top. So I can't just subtract this 6 away. The 6 isn't free. It's not lonely. It's not off by itself like this 3. Okay, it's stuck up there. So that means the first thing I need to do is actually get rid of this 9. So the first thing I'm going to do here is multiply. And that's totally different than what we did yesterday. But this is just a special case. Anytime you see a normal problem where it's just this plus this, okay, even if there's some kind of division going on, right? I'm still going to get rid of the lonely number first. But there really isn't a lonely number here. Everything's attached. It's a special case. I can't get to the 6 until I get rid of this 9. This whole bottom piece needs to go away. Then I can attack the top. So I'm going to multiply to get rid of division. All right, and as I bring this down, 1 times 9 is 9. And think about what's left over. If I eliminated this 9, the entire top is just going to come down. And there is no more bottom. So 6 plus n is all that's left. Then it's super easy. Now I want to get n by itself, so how do I get rid of a positive 6? How do I get it to 0? I am minusing 6. This goes away. N is left over. I think my answer is 3. So let's check it, because I just told you to do things totally backwards from yesterday. So if I'm telling you the truth and this answer is correct, it should work in a check. So let's make sure that it actually does. So rewrite the whole thing, but replace n with your answer of 3. So it's going to say 6 plus 3 over 9. So I need to complete this whole side and see if it comes out to 1. So first step is to add the top, so I get 9. I still have 9 on the bottom, and when I do 9 divided by 9, I get 1. And so my check works. Okay, so this answer is right. You can trust my procedures here. We need to clear out the bottom before we can attack the top. So if you look at number 2, same idea. We can't get to this n minus 6 until this 2 is gone. So to get rid of divide by 2 and reverse it, I need to multiply by 2. So they're going to go away. The only thing left is n minus 6. And on this side, 6 times 2 gave me 12. So if I want to get n by itself now, minus 6, I need to add 6 to get it to 0 and cancel. So I'm left with just n equals 18. All right, let's see if it works. Make sure you're writing the word check every time. Keep organized here. So I'm rewriting this whole thing. So instead of n minus 6, it's 18 minus 6 over 2 equals 6. Back to the original. One step at a time. 18 minus 6 is 12. And 12 divided by 2 is 6. 6 equals 6. We're good. Okay, number 3. First thing I need to do is get rid of this 8. So I multiply by 8. Got a couple more negatives to deal with here. So this goes away, leaving me negative 9 plus m. And on this side, 8 times negative 3 is negative 24. All right, one more step. Now, this goes back to some of the tricky one steps that we looked at. I see addition, so your first instinct might be to subtract. But we need to think about this negative here, and how do I get this negative 9 to 0? Because that's really how we cancel, is we get it to a 0. So to get a negative 9 to a 0, I have to add 9. Because if I subtracted 9, negative 9 minus 9 gets me negative 18, which means it didn't cancel, it got me a number. But negative 9 plus 9 gets me 0, and that's how it goes away. So I still have an m, and negative 24 plus 9 is negative 15. All right, let's see if I did all of that right. So back to the original, negative 3 equals negative 9. Instead of plus m, I'm going to put plus negative 15 over 8, one step at a time. Negative 9 plus negative 15 is negative 24. And negative 24 divided by 8 is negative 3. We're good. So let's go to number 4. You'll notice on number 4, I've got a negative down here. I'm still getting rid of this first. I can't attack the top until this bottom is gone. So I see an entire expression up top. Got to get rid of that bottom first. Special case. So I'm going to multiply by this number, negative 3. Not just 3, but negative 3. That's going to eliminate this. Leave me x minus 2. And on this side, I'm going to get negative 6. Minus 2, think of it like a negative 2. Subtraction and negatives are pretty much the same thing. So to get rid of a minus 2 or a negative 2, I need to add 2. So x is now isolated by itself, and negative 6 plus 2 is negative 4. Let's see how we did. Back to the original. 2 equals, instead of x, I put negative 4. And make sure you get that negative 3 on the bottom. That's going to make a difference. So negative 4 minus 2, we go plus a negative. That's negative 6. A negative divided by negative is positive 2. We're good. Okay, so those are one special case. Now let's look at some special cases that have to do with negatives, and things aren't sitting exactly the way we're used to seeing them sit. So when we look at number 5, it almost looks like a one-step. Okay, I need to get rid of this 3 for sure. It's the lonely number here. There's no fractions, no silliness to deal with there. So I need to get rid of this 3. Let's start there. Minus 3 on both sides like you would think. I'm going to get negative 17 over here. And now this entire thing is still here, so I can't get rid of it. So I'm not done. I don't want to know what negative x is. I want to know what x is. So there's a couple ways to think about it. This negative actually represents a number. It's really a negative 1 that's out front. And it's being multiplied by x. Whatever x is, it's being multiplied by negative 1 to get negative 17. So you might be able to think about what that number is. So anytime we've got a number attached to x here, it represents multiplication. So to get rid of it, we divide. So what are we dividing by? Negative 1. Now, dividing by negative 1, what happens when you divide by negative 1? Well, the number itself, the 17 part of it, isn't going to change. Dividing by 1 doesn't change it. It's still 17. But I have a negative divided by a negative. That creates a positive 17. These negative ones cancel. And now I have what x equals. X is 17. So negative x was negative 17, which means positive x is positive 17. Should make sense. The way you show your work is to divide by negative 1. All right, let's check it. Negative x, so negative 17 plus 3 equals negative 14. Try that in your calculator, make sure it works. It does. We're good. Okay, so when you end up with a negative x equaling something, you're going to have to divide by -1, and that will get you your answer. Basically, it's just going to turn this sign around. If it's negative, it becomes positive. If it was positive, it becomes negative. All right, number 6. This is when things can get a little tricky. So when I look at number 6, I see a lonely number 10. I'm looking at the left side of my equation because here's b, and I want to get rid of all of this. So I see my lonely number 10 that I want to get rid of. Good. Everybody recognizes that. So how do I get rid of this 10? Well, I see a minus, so you may think you want a plus. But let's go back to up here for a second. When we had a -9, how did we get rid of it? We added 9. So let's pretend this was a -10. It's not. But what if this was a -10? How would we get rid of a -10? We would add 10. So if it was negative and we would add, and now this is actually positive, we got to do the opposite here. All right. This subtraction has to do with the 10b. It doesn't have to do with the 10. That's not what's being subtracted. This is. In fact, I could change this to plus -10, right? Keep, change, change. Instead of subtracting, I could say plus a -10. So now I've made it addition, and I've just blown your mind, because if it's addition, that means I need to subtract. And that is actually what we need to do. We need to subtract. So from here on out, what you need to think about is just look at the number itself and how do I get that to a 0? Because that's how it's going to cancel. So since it's a 10, you're going to minus 10 to get rid of it. That's how you get a 10 to a 0. So don't worry about what's in the middle. Worry about what's in front of it. If it's negative, plus, like we did up here. Since it's positive, I'm going to minus. That gets rid of it. So this we said is a negative 10b. And 40 minus 10 is 30. So even if I didn't change this to plus a negative, I got to keep that subtraction sign with it as a negative. So subtraction is kind of like a negative, because if I make it plus a negative, it's the same thing. So now I want to get b by itself. I'm going to divide by the negative number. And 30 divided by -10 is -3. For the sake of time, we're not going to check these last couple. You check them just like all the others. So let's look at number 7. Here's v on the right side of my equal sign. So these two 4s, both negatives, need to go. They got to go. So I want to get v completely by itself down here. I'm going to start with the lonely number. It's a -4. I need the opposite. I need a +4. Make sure when you put the other +4, everybody knows we got to do it twice. Put it on the other side of the equal sign. So don't put it under this. If you need to draw that dotted line every once in a while to remind yourself, then draw it. Once on the right, once on the left. So not twice on the right. One over here, one over here. So what happens is the -4 cancels. This whole thing needs to come down, including the negative. So that's a huge mistake that students make, is they will just bring this down and call it 4v. And they say, well, that's a subtraction sign, not a negative. Yes, but I can always change subtraction to plus -4v. So this -4v needs to come down. So you need to treat subtraction like a negative in this case and bring it down. Now, -72 plus 4, that's -68. I divide to finish this off by the negative number. It cancels, leaving me just v. A negative and a negative make a positive when you're dividing. And this is 17. So let's try one more just like it. Here's n. Okay, we got to get everything on this side gone. 3 and 6 need to go. You start with the lonely number. It's negative, so I'm adding 3. It goes away. This minus 6n comes down as -6n. That doesn't make sense to you, then change it to plus a negative, and then hopefully you can see the negative needs to go with it. And this is 114. I need to divide to finish this off. And n equals -19. All right, you're going to flip this over and you're going to try the classwork.